In this video, we're going to talk about Chapter 13, conic sections. And when we talked about conic sections, we talked about 4 different kinds: parabolas, circles, ellipses, and hyperbolas. In this video, I'm going to show you examples of how to graph each type of conic section when the conic sections are in standard form. So we're going to compare to our standard equations, and we're going to be able to graph using information that we can glean from the structure of the equation. In my next video, we're going to look at conic sections that aren't in standard form. So let's start with this example here. I have a conic section. It's x equals y minus 4 squared plus 2. And the first thing I'm going to think about is, what conic section is this? Well, I noticed that I only have one squared term. And so if I only have one squared term, I know that this must be a parabola. So I'm going to be graphing a parabola. Okay, that's important information because now I know I can compare to the standard form of a x equals parabola. So let's compare to standard form. For an x equals parabola, standard form is x equals y minus k squared plus h. So right away I can see that h is 2 and k is 4. So that's going to be my vertex. So let's see, h is 2 and k is 4. All right, let's find some points. I'm going to plug in y's and get out x's because it's going to be a little easier. So let's see. I'm going to go 2 above, and I'm going to plug in y's. So I'm going to go 5 and 6, and 2 below, 3 and 2. All right, let's plug in. When I plug in, I get the points 6, 6, 3, 5, 2, 4, 3, 3, and 6, 2. So let's go ahead and graph these and see what this looks like. All right, 6, 6. Right there. Doesn't want to go. Let's try this again. There we go. 6, 6. 3, 5. 2, 4. And then I should have symmetry. So 3, 3, and 6, 2. Okay, beautiful. It's a parabola opening to the right. Looks something like that. All right, let's do the next one. Graph the conic section. All right, so I have to figure out what kind of conic section it is. I have 2 squared terms, both with the same coefficient. The coefficient would be 1. I can tell from that this is going to be a circle. So this is going to be a circle. Standard form for a circle looks like x minus h squared plus y minus k squared equals r squared. So comparing to standard form, I can see that I don't have an h and I don't have a k. Well, technically I do have an h and I do have a k. They just happen to be 0. So my center here is going to be 0, 0. So let's write this down. Center 0, 0. All right. What about my radius? Well, r squared is going to be 16. So what does that tell me? If r squared is 16, then r is 4. So let's draw this circle. Center is 0, 0. Okay, and r is 4, so I have to count 4 in each direction. 1, 2, 3, 4. There we go. All right, let's draw this circle. Okay, that's not the most beautiful circle, but it works. All right, so far we have a parabola and a circle. Let's keep going. Graph the conic section. I have to figure out what kind of conic section it is. I have two squared terms, and geez, I have this coefficient of basically 1/9. I can think of this as 1/9 as a coefficient for this squared term. And over here, I have a coefficient of 1/4. I can think of that as being 1/4. So I know this isn't the circle, because 1/4 and 1/9 are not the same thing. And there's also a plus sign here. So that's going to tell me that this is going to be a ellipse. Okay, so now I need to ask myself, is this a hot dog or a hamburger? Well, it looks like the number under my y term is bigger. So that tells me this is going to be a hot dog ellipse. All right, let's compare to standard form. Standard form for an ellipse is x minus h squared over a squared plus y minus k squared over b squared equals 1. So I can tell that my center is going to be 3, -1. So center is going to be 3, -1. My major axis is going to be 2 times b, because this is a hot dog style. So b is 3, so my major axis is going to be 6 units long, and my minor axis is going to be 2 times 2, and that's going to give me 4. So I'm getting 3 from the square root of 9, and I'm getting, so this 3 right there came from the square root of 9, and this 2 right here came from the square root of 4. Okay? Now, let's graph this. So my center is 3, -1, and my major axis is 6 units long, and it's hot dog, so it's in the y direction. So I'm going to split 3 and 3. Okay? And my minor axis is 4 units, so I'm going to split 2 and 2. Makes 4 across. And there is my ellipse. All right, last one. I bet you can guess what this is, but we'll talk about standard form. Okay, so this guy's got a coefficient of 1 over 25 for this squared term, and I have a coefficient of 1 over 9 for this squared term. So this isn't a parabola and this isn't a circle, but then this is key. There's a minus sign. So that tells me this isn't an ellipse either. This is a hyperbola. Standard form for a hyperbola looks like x minus h squared over a squared minus y minus k squared over b squared equals 1. And this is for a hyperbola with the x term in the lead. Okay, so because the x term is in the lead, I know this hyperbola is going to open right and left. So I'm just going to make a quick note of that to myself. So this hyperbola is going to open right and left. Okay, because the x is the leader. So let's start with the center, h and k. Oh, I don't have an h and I don't have a k. So I know my center is going to be 0, 0. Okay. Now let's talk about asymptotes. Asymptotes are those guidelines. Asymptotes are going to have a slope. They're going to go through the center, and they're going to have a slope of plus or minus b over a. So for this particular problem, let's see, b is going to be 3 because the square root of 9 is 3. So I'm going to have plus or minus 3 over, and a is going to be 5 because the square root of 25 is 5. So I'm going to have asymptotes with a slope of 3/5 and -3/5. So let's get this thing graphed. Alright, so I have my asymptotes drawn. Now I need to think about my vertices. So I know this guy's going to open right or left, so I'm going to use my a value for my vertices. My A value is 5. And that came from the 25, remember? So what I'm going to do is I'm going to start at the center, and I'm going to count 1, 2, 3, 4, 5 to the right, and put a point. Okay. And then I'm going to start at the center and count 5 to the left. Okay. And put a point. Okay. So those are going to be my vertices, and then I'm going to use my guidelines to draw those vertices, or to draw the hyperbola. So let's see what this looks like. Let's do it in green. Alright, so starting at my vertex there, and I get close to the asymptotes, but I don't cross. Alright, all 4. Parabola, circle, ellipse, and hyperbola.